Now in this video we're going to look at the RC time constant really quickly. And so when you charge a capacitor through a resistor, the capacitor is already charged, and I put an LED in series with the resistor. The capacitor, right now current is going through the switch, so the LED is going to stay lit right there. But now the capacitor is charging. You can see the LED is dimming over time. Now it was bright at first and got dim over time, as I said. That is because there was more current flowing at first, and the capacitor started charging quicker at first. So I'm going to grab my oscilloscope here, and I just have the alligator clips for the oscilloscope, and I just clip them to jumpers, and then I can put the jumpers into the breadboard, the black one here with the blue wire that it is clipped to. We want to go to the negative rail. That way we have a voltage in relationship to the negative rail. And so the capacitor's not going to charge all the way up to the rail. Right now, there you can see we got some more right there. There's 8 squares there. Each square is a volt, and then each square is a second going across. And that's because the LED is blocking about 2 volts. And there you can see we have 7 volts at the power supply. And in any case, now we're going to look at the waveform. So as long as I hold it, it's going to keep the capacitor discharged to nothing. But I let go. There you can see that it is charging. And another thing, we're using a 1 kilo ohm resistor and a 1000 microfarad capacitor, which is about 1/1000th of a farad. So we got 1000 times 1/1000th. That gives us 1 second for 2/3 of the charge. And so the next second will give us 2/3 of what's left, and then 2/3 of what's left, 2/3 of what's left, and so on. But we generally stop at 5 time constants. 1, 2, 3, 4, 5. There you can see it's pretty much fully charged. A little bit more might trickle in, but we consider that fully charged. So that is the RC time constant. And here I added an LED for visual effect, and it blocks pretty much a certain amount of voltage no matter what. It shifts a little bit based on how much current is going through, but for the most part it now there's an open connection because I removed the LED. But we will take the resistor here, put it to the switch. Now you can see that the capacitor charged as soon as I attach the resistor up to 7 volts. But again, we had a certain amount of voltage block, so I didn't quite make it to that line. We're a little off to the right. But again, you're going to see here that now instead of about 5 volts, we're dealing with about 7 volts that the capacitor will charge up to. There's a 1, 2, 3, 4, 5, and then right up there, that's pretty much a fully charged. Plus it went over a little bit because that's a little over to the right. So that is the basics of RC time constant. I added a switch and an LED earlier, made it a little more confusing, but that's pretty much what we got on the oscilloscope reading once I let go of the blue button right there. The voltage shot up quickly at first and then kind of leveled off. But you can do the math. You don't really want to use higher value capacitors for this circuit. That'd be kind of a lot of current to short circuit. But you can go any amount lower you want, and resistors you can go a bit lower or a lot higher. You can balance them out, and the resistance in ohms times the capacitance in farads. So 1000 microfarad is the same as a millifarad. Microfarad is 1 million farads, but for some reason you rarely actually see people use millifarads. And usually if it says MF, they used an M instead of the mu symbol. And so that's something you gotta be aware of. But in any case, usually when you talk about capacitance, these lower value capacitors, regular capacitors, they're in microfarad or nanofarad or picofarad. So 1000 microfarad is 1/1000th of a farad. So 1000 times 1/1000th, 1 second. Makes the math easy. And as we saw before, that only gives us the time that, okay, I wrote it up here, the time to 2/3 of a voltage change. So there's the power supply voltage, 7 volts, and then whatever the capacitor voltage is, it's changing. And it holds steady until we short circuit that, it goes down, and then it rises, it changes till it levels off. And so that is the 1/5 of the change is 1 second, and so over 5 seconds it'll get fully charged, and each time it's going to get 2/3 of the way closer to its final destination from where it started at that particular time constant. So in any case, hope that all made sense. Thanks for watching. I'll see you in the next video.